Good morning, students. And today is the last class of highway lighting, and we learn about the layouts of lighting, coefficient of utilization and maintenance factor, and we will also do one numerical on spacing of lights. Yeah, so let's start with the layouts of lighting. Yeah, and first we'll see on straight roads, yeah, how the lights are laid and what is the type of distribution. So on straight roads the lighting layout may be of following types. First is single side. Yeah, you can see that spacing 30 to 60 meter, and on one side of the road the lightings are provided. Now it is economical to install, but it is suitable only for narrow roads. Due to cost considerations, even on two-lane roads, often single-side lighting is adopted. So spacing 30 to 60 meter. Now next type is staggered, and as you see, it is both sides. The lights are placed both sides, and it is not directly opposite to each other. That's why it is called staggered. So for wider roads with 3 or more lanes, this system is adopted, and spacing you can see in the figure is 30 to 60 meter, yeah, between lights. Okay, now for central layout, it is also used for wider roads with 3 or more lanes, and spacing is 30 to 60 meters. Yeah, you can see in this figure that the lights are laid centrally, yeah, and with a spacing of 30 to 60 meters. Now, the spacing of lights in each of these systems is decided based on various considerations. Now, what are these considerations? These are location, lamp size, height of mounting, and lighting requirements. Okay. Now, how we will find this spacing will become clear when we solve one numerical on it. So, let's proceed ahead. How lighting layouts are done on horizontal curves. Yeah, you can see these are horizontal curves. Yeah, and the distance between lights, you can see along curves, it is less spacing is there between lights because in order to have better visibility. Now you can see here on a straight portion it is 50 meters, and on curved portion it is 30 meters. Yeah. Similarly here on horizontal curves, yeah, you can see here it is 35 meters on bends, yeah, and on straight portion again 50 meters, and on bends again 35 meters. Yeah, so this is the layout of lighting on horizontal curves in case of roads. Now, what is the type of layout at intersections and crossroads? Now you can see here, this is T intersection. One road is coming here and this is joining the main road. Yeah. So this is on straight portion, the distance is 50 meters. It is a staggered type. Yeah. And on bend, yeah, you can see this distance here is 15 meters. And again, this is 50 meters. Yeah, like that. And opposite side, you can see a central light here. It is 25 meter distance from these two. And again the straight portion as 50 meters. Now in crossroads, this central line, yeah, is again 25 meters to the adjacent staggered light, and it is 60 meters in case of crossroads on straight portion. Okay, this is your 60 meters. This is, and now this one is again 30 meters here from center line, and here it is again 30 meters. So this distance is also 60 meters. Yeah, like that. And this one, like the first light on this road and this light, yeah, this horizontal distance center to center, yeah, this one on opposite staggered ends is 50 meters. At intersections, due to potential conflicts of vehicular and pedestrian traffic, more illumination is required. Okay, ज़्यादा रोशनी चाहिए होगी हमें intersections में. For simple intersections in urban area, the illumination should be at least equal to the sum of illumination values for two roads which form the intersections. Okay, तो यहाँ पे जैसे आप देख रहे हैं यहाँ पे 25 मीटर या distance, and here it will be 50 meters distance. Okay, like that. Now let us come to the next topic, that is coefficient of utilization कैसे निकालेंगे और maintenance factor क्या होता है. Okay, now for various types of linear distribution, utilization coefficient charts are available. You can see in this diagram, on y-axis is coefficient of utilization, value ranges from 0 to 0.5, and on x-axis there is one ratio, width of area divided by mounting height. Okay, so here, like from this you can find out the coefficient of utilization. So utilization coefficient charts are available for determination of average intensity of light in lux over the roadway surface, where lamp, lumen, mounting height, width of paved area, and spacing between light poles are known. Okay, so how we find the spacing between lighting units is equal to lamp lumen into coefficient of utilization, which we find from this curve, into maintenance factor, which we take as 0.8 or 80%, divided by average lux into width of road. So this is the formula by which we get the spacing between lighting units. So what are the factors we must know in order to calculate spacing between lighting units? We must know the lamp size, we must know coefficient of utilization, we must know maintenance factor, we must know the average luminosity of road, average lux, and into width of the road. Yeah, like that. So the maintenance factor takes into account the decrease in efficiency of lamp with age, and an average value of about 80% may be assumed. So this graph will be very much useful for finding coefficient of utilization, and you can see here this is the street side and this is the house side. Okay, now next but not the least, let's solve one numerical in order to make our concept clear how to find the spacing between the lighting units. Now this numerical was also asked in RGPV examination, so please concentrate on it. Calculate the spacing between the lighting units to produce a lux equal to 7 from the following data. Width of road is given 14 meters, mounting height 8 meters, lamp size 7000 lumen, and it is luminar type 2 distribution. Okay, in previous slides we have seen what are the types of distributions. So type 2 distribution is for narrow roads, and where it is the staggered lights we can give like that. Now average lux in solution, first we'll write what are the given things. Average lux is given as 7, street width is given as 14 meter, mounting height 8 meters, lamp size 6000 lumen. No, it's wrongly written, it should be 7000 lumen. Now ratio pavement width by mounting height is equal to 14 by 8. That is, pavement width is 14 meter and mounting height is 8 meter, and you are getting 1.75. So from this figure, previous figure, if you get this here 1.75, okay, now on the street side it will be approximately 0.32 as the coefficient of utilization. So here it is written 0.32. Now assume maintenance factor 0.8. Now spacing of lighting units, we have the formula, is equal to lamp lumen, that is 7000, into coefficient of utilization, that is 0.32, into maintenance factor, that is 0.8, and divided by average lux, average luminosity is given as 7, and into 14, that is width of the road. So it comes out to 1792 by 98, and that is 18.3 meters is the answer of the spacing of lighting units. So hope students you have understood today's lesson of what are the different layouts of lighting. We have seen on straight roads, on single side, staggered fashion, central fashion. We also seen how it is done in case of horizontal curves, We also saw how it is done at intersections like T intersections and crossroads. We also saw what is coefficient of utilization, how it is found out from a graph, and maintenance factor. And also we solved one numerical. Okay, so all the best. Please submit the assignments. Hope you have understood the highway lighting unit, which is unit 4 of your traffic engineering.